Hey everyone, we are now moving on to 11.3, which is all about circles. So we've already talked about our area of a circle before, so just in case you forget, that's our formula pi r squared, and make sure you're just squaring that r, you're not squaring that pi times r. We'll also need to remember our circumference formula, which remember we have two of those. We have 2 pi r, or remember 2r is the same thing as our diameter, so we could do pi times our diameter, okay? So for a sector of a circle, we have a region of a circle bounded by a central angle and its intercepted arc. So to draw that, you're going to start with your center of your circle, and then you're going to draw 2 radii here, okay? So I'm going to go ahead and highlight this section here, and this right here that I just highlighted in yellow is your sector, just a section of that circle bounded by our central angle and that arc, okay? So depending on what book you use, some of them go ahead and label it just like this, so we could say that's sector A. That's what your book's going to do, but sometimes they will name it a little bit differently, okay? So I'm going to go ahead and put my X here in the center. That's going to be my central angle, and then obviously, like I said earlier, this is our radius here. So for the area of a sector formula, okay, we're going to do our central angle, so in this case X based off our drawing, divided by 360 times the area of our circle, so pi r squared, okay? Now, I'm going to go ahead and do number 2, 5, and 7 with you guys in this video, and then the rest is going to be for you guys to figure out on your own. But if you have any questions on those, obviously feel free to send me a text or a email, okay? So moving to number 2, this one's not using our new sector information, okay? But I did want to go over this just because we haven't practiced a shaded region really yet. So we have to find the area of our shaded region, and we're allowed to assume that E is the center of both those circles. So I went ahead and already labeled that EG is 3, because if I know that HG is 6, and we're assuming that E is the center of that small circle, we can assume that EG is a radius, so it would be 3. And we see that GF is 6.5, and then our radius of our huge circle would be EF, and that's obviously going to be 9.5. I'm just adding that 3 and that 6.5 there. Okay, so to find the area of this shaded region, our total area is going to be, or our area of our shaded region, I should say, what we're going to want to do is take our area of our big circle and subtract the area of our smaller circle here. So I'm going to go ahead and write area of circle, I'm going to say EF, because we're talking about the circle with radius EF, minus the area of our circle EG in this case. Okay, so for our first step to start going about this, we're going to go ahead and find the area of circle EF. Okay, so again, that's easy. We just have pi r squared, and we already found our radius, so we're going to do pi times 9.5 and square that. And if you enter that in your calculator correctly, again, only squaring that 9.5, you should get 283.53. And again, since we don't have inches or centimeters or anything, I'm going to go ahead and write units squared. Same idea now for my circle with EG as the radius. That's going to be pi times 3 squared. And if you go ahead and enter that in your calculators, we should get 28.27 units squared. So be careful. When I taught this last year during student teaching, a lot of kids just stopped right here and they forgot to complete the problem, okay? So make sure you do that final step here, our total area, or our shaded area, I should say. So maybe I shouldn't have written total, but shaded area will equal our area of circle EF, so that 283.53, minus our 28.27. And when we enter that, we should get 255.26 units squared. Okay, so anytime you have problems like this where there's a shaded region, always just find the biggest region and subtract those non-shaded parts from it, okay? So moving on down here, our next problem we're going to do together is problem number 5. So this one is using our new sectors information here. And we have the area of our shaded sector is 77, and we want to find x. So we're going to go ahead and use that new formula. Again, remember it's going to be x over 360, or I should say our central angle over 360 times pi r squared. So we already know that that's 77. So I'm going to start off by saying 77 is going to equal 3x, that's our central angle, over 360 times our area of that circle, so pi times 11 squared. Okay, so I'm going to go ahead and simplify that just a little bit more. We'll have 77 is equal to 3x times pi times 121 all over 360. Again, our next step now, moving on, just using basic algebra here, I'm going to multiply both sides by 360, and I will get 27,720 equal to 3x times pi times our 121. And I'm going to go ahead and divide both sides now by 3 pi times 121 to get my x by itself. I don't like dividing by pi until the very end, so that way I know I'm not having a rounded decimal answer within some of my work, okay? And once we enter all that in the calculator, we should get 24.31 equal to x, okay? So remember, technically that's in degrees, and our central angle, we would do 3 times that, but we did just need to find x in this case, okay? So moving down here to number 7, this one's a little bit trickier than the last two we've done, okay? So again, we want to find the area of our shaded region. So what I'm going to do first is find the area of my circle, and then I want to subtract the area of my triangle. So again, I'm going to go ahead and write that out. So area of circle minus area of triangle will equal our shaded region. So I'm going to go ahead and find my area of my circle first. So our circle area is going to be our pi r squared. So remember, here we see that DC is 25, and to find our radius, we just got to divide that by 2. So that's going to be 12.5. So our area will be pi times 12.5 squared. And if we go ahead and enter that in our calculator, we should get 490.87. And then for our area of our triangle, we have to actually do something before jumping right into that. We see that we have our hypotenuse and we have one of our side lengths, but we need our other side length to do our 1/2 times base times height for our triangle. So we need to find what EC is. Okay, I'll do that here in blue. So EC, we're going to just use our Pythag. So we have EC squared plus 10 squared is going to equal 25 squared. And again, you got to make sure you're having equals our hypotenuse squared. I've noticed on the past few assignments you guys have turned in, a couple of you keep messing up your leg squared plus leg squared equals hypotenuse squared. Okay, so just be careful. So once we do that, we should get EC squared plus 100 is equal to 625. So EC squared, going a little bit further, is 525. And again, to solve, we're just going to take our square root, and we should get 22.91. So now that we have that, we can find our area of the triangle. So area of triangle DEC, that's going to equal to 1/2. Make sure you have that 1/2 times our base, which we just found is 22.91, times our height, which we can see is 10. And again, once we enter that in our calculator, we should get 114.55. So our final answer now, I'll do here in purple, our area of our circle minus our area of our triangle. So I'm going to do circle A minus triangle DEC. That's going to be 490.87 minus that 114.55 we just found. And once we do that, we should get 376.32. And again, make sure you have your unit. So in this case, feet squared. Okay. That is all I have for this video then. Make sure for your homework you are not looking at that syllabus, you're looking at what I posted. I think I cut it in half for this section. And then the only other thing I want to mention is for number 8 here, since you're dealing with just half of that circle, you're just going to find half of your circle areas and then subtract them just like we did in that example in number 2. Okay? All right, if you have any questions, please feel free to reach out.